Hey everyone, today we're going to be moving on to section 4.3 and we're going to be talking about derivatives of inverse functions. So in order to do that, we need to kind of remind ourselves what inverse functions are. And so we'll do a little practice of that before we actually talk about taking their derivatives. So an inverse function is just a function that takes all of the outputs of the original function and gives the inputs of the original function. So for example, we're going to do a quick exercise here. We're going to find the inverse function of f of x equals 4x cubed minus 1, and then we're going to make a table of values for both our original function and the inverse. So if you think back to pre-calc and even more recently our summer packet, in order to find the inverse, I'm going to rewrite this as y equals 4x cubed minus 1. And we know to find the inverse, we're first going to switch x and y. So I have x equals 4y cubed minus 1. And now my job is to solve for y, and that's going to give me my inverse. So in order to do that, I'm going to start by adding 1 to both sides. Next, I'm going to divide by 4. So I'm going to just move this over. I get y cubed now equals x plus 1 over 4. And the last thing we need to do is take the cube root. So we get y equals the cube root of x plus 1 over 4. And that's going to give me my inverse function. So f inverse of x is the cube root of x plus 1 over 4. So now we want to look at a couple things. We're going to make a table of values for our original function and the inverse. So I'm going to make one table over here. And this one I'm going to say is for my original function. And so I'm just going to pick some values centered around 0. So let's do -2, -1, 0, 1, and 2. So we're plugging them into our original function to generate those y values. So if I plug in a -2 cubed gives me a -8, times 4 is a -32, and then when I subtract 1, I get a -33. If I plug in a -1, I get a -1 times 4 is -4, minus 1 is a -5. 0 is going to give me a -1. If I plug in 1, I'm going to get 4 minus 1 is 3. And if I plug in 2 cubed is 8 times 4 is 32, minus 1 is going to give me a 31. Now I'm going to make a table for my inverse. And we said earlier that that inverse function is a function that takes all of the outputs of the original function. So it's going to take these outputs as its inputs. So let's do that and see what happens. So now my outputs of the original become my inputs to the inverse. So -1, 3, and 31. And now I'm going to put these into my inverse function to generate my y values. So if I plug in a -33 plus 1 is a -32, divide by 4 is a -8, and the cube root of -8 is -2. And you can notice already what I expected to happen is happening. This is taking the outputs of my original, and it's giving me, as its outputs, the inputs of the original. So if I keep going with this, -5 plus 1 is a -4. Divided by 4 is a -1, and the cube root of -1 is -1. -1 plus 1, that gives me 0. Cube root of 0 is just 0. 3 plus 1 is 4. Divided by 4 is 1. The cube root of 1 is 1. And then lastly, if I plug in 31 plus 1, that's a 32. Divided by 4 is 8. And the cube root of 8 is 2. So what I want you to notice, and what's going to become kind of key for us when we're finding these derivatives, is that this process of taking the inverse switches the x and y values. And so what we notice is now that the inputs of the inverse function, the inputs of the inverse function are the outputs of the original. And again, that's going to be key for us when we talk about finding their derivatives. So the input of the inverse is the output of the original. And so with that in mind, let's go ahead and take a look at how we actually find the derivatives of inverse functions. And what we've tried to do here is give you a pretty straightforward process for finding these derivatives. It's going to be a 3-step process that's going to work every time we're finding the derivative of an inverse function. Okay, and so again, our goal is to find the derivative of that inverse at a given value. So here's what our formula is going to look like. And just to kind of clarify what we're talking here, our inverse, right, when we're talking about this f inverse prime, we're talking about the derivative of the inverse. Now remember, we said that the input to the inverse is the output of the original function. So this y value here is the y value of the original function. Okay, so that derivative of the inverse at that given y value is going to be 1 over f prime of x. F prime is the derivative of the original. Okay, and that x value is the corresponding x value that matches the output y. And we're going to go through several examples that'll give you an better idea of what's going on here. Because I'm sure already, as it says here, it seems confusing at this point. So we're going to give you a process to help clarify what we mean here. So here's the 3 steps that'll help walk you through finding these derivatives. The first thing we're always going to do is we're going to take the derivative of the original function. Okay, so we're going to find f prime of x. Now, the next thing we're going to do is we're going to write 1 over f prime of x. And we'll walk through an activity in class tomorrow that'll tell you where this comes from. Right now, we're just going to kind of iron out the process, but tomorrow we'll really talk about where it comes from. Now, the next thing we're going to do is use our given y value, so the y value that comes here, and that will be given to you in these problems. We're going to use that to calculate and plug in the associated x value. And then that's going to help us to evaluate the derivative. So let's look at some examples to see what this looks like in practice. So my first problem says my function f of x is x to the 5th plus x plus 1, and it wants me to find the derivative of the inverse at the value 1. So the first thing we said we were going to do is find the derivative of f of x. So here we have a really straightforward power rule problem. So my derivative is just going to be 5x to the 4th plus 1. So there's my derivative. Now in the second step, we said we know that the derivative of the inverse at our given y value is going to be 1 over f prime of x, or 1 over 5x to the 4th plus 1. And so writing it this way is going to help us differentiate between the y value and the x value that we actually need to calculate. So we know the derivative of the inverse at the given y is 1 over f prime of x. And so now we're going to do step 3, and what we need to do is use this given y value. Again, remember that this value here is a y value of our original. That's our y value of f of x. We're going to use that to calculate the corresponding x value. So what I'm going to do is take my function f of x, which is x to the 5th plus x plus 1, and I'm going to set that equal to the y value of 1 so that I can solve for the corresponding x, which I need to calculate my derivative. So the first thing I'm going to do is I'm going to subtract 1 from both sides, so I get x to the 5th plus x is equal to 0. Now if I factor out an x, I get x to the 4th plus 1 is equal to 0, which tells me that either x is 0 or x to the 4th plus 1 is equal to 0. Now I know that any number to the 4th power is going to give me a positive number, so this is never going to be equal to 0. So this x equals 0 is the value that I'm looking for. So now our last step is to go back to our formula in 2, and we're going to plug in this x value into our derivative. So now I know that f inverse prime of 1 is equal to 1 over 5 times, and again I'm going to take this x value, so I'm going to show in pink that that's the same value, 5 times 0 to the 4th plus 1, which is just equal to 1 over 1 or 1. And that's the value of my derivative. So f inverse prime of 1 is equal to 1. Okay, so we're going to go through a few more examples so we can just have a few more exposures to this process. It's going to be the same process every time. So again, I have a function, and I'm finding the derivative of that inverse. And again, this value here at this y value, negative 1. So our first step is to come up with f prime of x. And an interesting thing happens here because our derivative is just that constant 2. So now, in my second step, I know that the derivative of my inverse at any y value is 1 over f prime of x, which is 1 over 2. And now since I have a constant derivative, I actually don't need to go back and solve for x because I don't have an x in my derivative. So in this case, we're spared a step, and we know that the derivative of the inverse of f at negative 1 is just 1/2. So that was a little easier because we ended up with a derivative that didn't involve x. All right, number 3, same process. And hopefully by repetition, this will just something that will become automatic, and you'll remember to go through these 3 steps. So step 1 is to find my derivative, which is 3x squared. Step 2, I know that the derivative of my inverse at the given value is 1 over f prime of x. Step 3, I'm going to use this y value to solve for x. So I have the equation x cubed minus 1 is equal to 7. So I'll solve it by adding 1 to each side, and I get x cubed is equal to 8, or x is equal to 2. And again, this value is what I need to calculate my derivative. So now I know that the derivative of the inverse of f at 7 is equal to 1 over 3 times, and again, this value is here. My x value is 2 squared, and so my derivative is 1/12. All right, we'll do one more for today, and that'll be enough. So number 4, again, same process. And to help me out here, I'm just going to rewrite this as negative x minus 2 to the 1/3 power. And so we're going to have a basic chain rule to deal with, but it's not going to impact our process too much. So the first thing I'm going to do is find my derivative. And so I'm going to use my power rule first for the outside. And then I'm going to multiply by the derivative of the inside, and that's going to give me a factor of -1. Now, I'm going to rewrite this a bit, only because rewriting it as a fraction is going to help me when I need to take 1 over my derivative, or really find the reciprocal. So this is equal to -1 over 3 times negative x minus 2 to the 2/3 power. I'm making that positive when I bring it down. So that's my derivative. Now, in the second step, I'm going to take 1 over that. And again, really all that involves is taking the reciprocal. So in this case, instead of -1 over 3 times negative x minus 2 to the 2/3, if I were to take the reciprocal, this is going to come back up top. So I have -3 times negative x minus 2 to the 2/3. And so again, writing it as a fraction here helped me to more easily deal with the reciprocal in step 2. Step 3 is the same. We're going to take our y value and set it equal to our original function. And we're going to solve. So taking the cube root gives me negative x minus 2, or excuse me, cubing both sides, gives me negative x minus 2 is equal to 1. So I get negative x is equal to 3. Let me scoot this up. Or x is equal to -3. And again, I'm going to take this value, and this is going to go into my step 2. So now I know that f inverse prime of 1 is equal to -3 times the opposite of -3, which would be a +3 minus 2 to the 2/3. So I get -3 times 1 to the 2/3, which works out nicely because we know that 1 to any power is still going to be 1. So our answer is -3. So I know that the derivative of my inverse at 1 is equal to -3. So this is something that's just going to take repetition to get used to this process, and we'll be doing plenty of that. The end.